easier? I don't know. Can I solve these tasks? Well, let's find out. Quad this is week 78 of the Perl Weekly Challenge. It's been a few weeks since I last did one of these. Let's see what's up. An array of integers, distinct integers. Find leader elements. Greater than all the elements to its right. This should be pretty doable. Right. 9, 10, 7, 5, 6, 1. My instinct is to reach to a greater than selfie outer product, and you can kind of see how maybe the less one will get us more info, but how 10 is not. Oh, 10 is greater than all of the ones to its right, as is 6. What does this tell us about 7? We don't get quite the same pattern, because 9 would indicate that, so this ain't the one. To its right. That's what I'm thinking I'm on the right track, because this compares each element to all other elements. So this is 9 compared to all the others, and it's greater than. So that's like, is 9 greater than 9? No. Greater than 10? No. Oh, since they're distinct, we don't care about greater than or equal. And if it's the first one, so an and scan. That only indicates 10. Oh yeah, because they're all zeros. Get the flip side. Compared to... So what I'm thinking is some kind of scan of this outer product compared to the outer product itself should indicate whether they were all greater than elements to the right. But your starting element is an edge case for this type of thing. It shouldn't be. 9 is not 1. 10 is 1. 7 is 1. 6 is not. You know what I'm saying? So we can do like and scan match rank 1. I'll get fucked. Right tack. And this indicates 10, 7, 6, and 1. Is this your boy? Sorry, I'm not verbalizing the thought process very well. I'm kind of just staring at matrices to see the pattern, but I think this is the guy. Can I reason my way out of it? Not entirely sure. Something like the outer product compares all numbers to all the other numbers. And this time we're giving it a less than relationship. So is 9 less than 9? Is 9 less than 10? Is 9 less than 7? Etc. Is 10 less than 9? Blah, blah, blah. And then the and scan is basically all ones until the first 0. And what does this mean? Well, it's good for doing these types of left to right, right to left relationships, like all of the ones to the right, all of the ones to the left. So you see these a lot in your idioms for removing leading blanks, trailing blanks from text vectors. Christ. So if a number is greater than all the elements to its right, then all the elements to the right of that element will be zeros in the overall outer product. Is this right? Is this how it works? Yeah. And therefore the and scan will have no effect on that row, and so they'll match each row. That's what the match rank 1 here is doing. It's comparing each row to each row and seeing if they're identical. Alright, you know what? Did it. So then it's just omega compressed by that, and there's your numbers. So leader element, the elements, omega distinct integers, return elements which are greater than all elements to their right, and it's omega compressed by and scan match rank 1 outer product less than selfie omega. 6, 2, 4, 8. All the elements to its right. 9, 10. Oh, because they have to be going. Essentially, you need large ones on the left to make this work. 5 is larger than all the ones to its right. What have I done wrong? Is it not? Oh. What? Yeah, so that would give the right result in that case. I think I am mistaking the criteria here. This is not one that would return 10 is greater than all of its to its right. 3 is not, 1 is not, 5 is not, 2 is not, 6 is greater than 1. Alright, so maybe the test cases aren't that good. Let's just compare. 10 is greater than all the ones to its right. Yeah. 3 is not, 1 is not. 5 is greater than all the ones to its right, and 3 is greater than all the ones to its right. So why did it work on this guy? Because 9, 10, because they were only descending, I think. So my logic was full of shit. Okay, 10 is fine because it's just outright the largest. Problem comes with 5, and they don't match. If it's all greater than elements to its right, maybe there's something about, I want to say upper triangle, because it's really, we're looking for just this type of pattern. So you start from a 1, not a 1. Where's the number? The number itself will be on the leading diagonal. That'd be a 0. Also, we don't care about ones to the left. We just want all zeros on the right, the top right triangle. So that's going to be the only criteria, I think. So one way is to just do the dot less than selfie iota omega. That's the upper right triangle, and those together. And we're looking for ones which are all zeros. I think 0 equals or slash 10, 5, 3, and 1. This. Okay, now I've actually thought about it a bit. This makes more sense. We were on the right lines before, just needed to make the logic more sound. So, thank God I checked that. 9, 10, 7, 5, 6, 1. Still gets the 10, 7, 6, 1. And 3, 4, 5 will obviously be 5. That's the correct solution. Copy this. Place that there. Brilliant. Okay. If we want, later I can check for distinct elements, and that's just unique matches the original. So, for example, 9, 10, 7 is unique. 9, 10, 9, 10, 10 is not. Alright, but I'm going to move on now. An array containing positive numbers, and B containing one or more indices from A. Rotate so that the number at the first index of B becomes the first element in the array. No, it's rotate, then left rotate A again. I'll look at the examples. It'll clarify so that the number at the second is the first element. We can go with their examples. 10 times 0 to 5, and 3, 4. Left rotate. Oh lord, okay, well I'll make index origin 0 just to fit with their thing. Oh, sorry, no, the fourth element, element 3. So is that just a 3 rotate? Uh-huh. And then left rotate the fourth element to make it the 0th index number. Oh, and then output both. So that's just omega rotate rank 099 alpha. Yep, it's nice when it's basically built-ins. Example 2, again, this should just do it. 7, 4, 2, 6, 3, rotated by 1, 3, 4. And we get 42637, 63742, 37426. There's nothing really much to be said about this other than it's the rotate primitive, and you want to apply it with a list of scalars. I'm going to rotate each of those scalars. Just make sure that the index origin is 0 to get the correct amount, otherwise you'll get an off by 1 error. So we call it left rotation. And really, apart from just local, set quad O to 0. In fact, if you want to make it, there you go, now it's high rank. Rotate major cells in omega by scalars in alpha. No, that's a lie. Omega alpha. Rotate major cells in alpha by scalars in omega. I mean, that's literally what the APL says. Don't think there's loads to say. I mean, when there are array-based challenges, then that's just APL's thing. Oh, I also need to correct this. Okay, so I've spotted a little artifact from my noodlings. No, the fact that in leader element you have to find which are greater than all elements to their right means there's no way of avoiding this sort of n squared solution. You have to compare each element to all the elements. So an outer product is the easiest way to do that. And then the rotation was just kind of neat, because after struggling to pass the English, it turns out it's just the rotate primitive applied with rank. Thanks very much again for watching. See you the next time I do this.